Hello viewers, this is Prof 1 Tutorials. My name is Alfred Amprofi and you are here this time around to look at mensuration. Mensuration. Mensuration has been divided into two parts. We have the mensuration 1 and the mensuration 2. The mensuration 1 typically talks about the perimeter and area of plane figures. For example, a square, a rectangle, a circle, or the quadrilaterals. For example, parallelogram, the trapezium, rhombus, kite, and other quadrilaterals we have. But today we are going to look at mensuration 2. Mensuration 2. The mensuration 2 also talks about the volume and the total surface area of solid figures. The volume and total surface area of solid figures. When you talk about the volume, it's how much a solid figure can take a specific quantity of a substance. So it can be a water or anything of liquid, how a solid figure can contain it. So let's take some few notes. It talks about the volume and total surface area of solid figures. So this is all about mensuration 2. So mensuration 2 talks about the volume and total surface area of solid figures. So we are going to look at some of the solid figures we have. Now with the solid figures, we have two main parts. We have the prisms, and we also have the pyramids. So we have the prisms and we have the pyramids. But we are going to look at the prisms afterwards. We look at the pyramids. Now, when you talk about the prisms, is when the top of the solid figure is the same as the base of the solid figure. So the first prism we are going to look at is the circular prism. So when you look at the circular prism, the top is in the form of a circle. The base is also in the form of a circle. So the top is equal to the base. And this is typically called the cylinder. The cylinder. And a cylinder looks like this. So we have a circular top. So we have a circular top and then a circular base. Every cylinder has a common radius. So the radius of the top or the circular top is the same as the radius of the circular base. So R is here, another R is here. Then we can get the height of the cylinder. The height of the cylinder. So this is the first prism we have. We also have the square prism. So now let's get a square prism. So the square prism, basically we call it the cube, is also called the cube. So every cube has a top square, then the base is also in a form of a square, and it also looks like this. So this is a cube. The third prism is the rectangular prism. So with the rectangular prism, basically we also call it the cuboid. The cuboid. So every cuboid has a rectangular top as well as a rectangular base. So this is a cuboid. Then the last one is the triangular prism. The triangular prism. With a triangular prism, it also has a triangular top and a triangular base. So it also looks like this. So when you look at the figure we have here, we can see a triangle, another triangle. Now this sketch can also be drawn like this. Yes, like this. So a triangular top and then a triangular base. So basically when you talk about prisms, this is when the top of the solid figure is the same as the base of the solid figure. Now the next one is pyramid. Pyramid. A pyramid has a conical top. So the top of a pyramid looks conical. So every pyramid has an apex, or we also call it the vertex. So the first pyramid is the circular pyramid. The circular pyramid. We normally call it the cone. A cone. So for a circular pyramid, its base is in the form of a circle, but the top has a conical shape. So the top we call it the apex or the vertex. The apex or the vertex. Every pyramid has height and then the radius of the cone. Now the second one is the square pyramid. Number two is the square pyramid. So the square pyramid also has a square base and a conical top. All right. So this will be our square pyramid. Then the next one is the rectangular pyramid. Rectangular pyramid. So with a rectangular pyramid, it also looks like this, where we have a rectangular base, then this is its height. All right. So the rectangular pyramid also has an apex or the vertex, and the top looks conical. The last one, which is the fourth one, is the triangular pyramid. The triangular pyramid. So with the triangular pyramid, it also has a triangular base. All right. So this is the triangular pyramid. So this morning, we are going to look at the circular prism, for which we also call it the cylinder. How the volume and then the total surface area is found. So viewers, let's get started. So as I said earlier, every prism has the same top as well as the same base. So when you look at a cylinder, in most cases, our mind cast on gas cylinders. But basically, every cylinder is any solid figure that has a circular top and a circular base. So we can say that a cylinder has a circular top as well as a circular base. Okay, a cylinder has a circular top as well as a circular base. So let me give a sketch of it. So this is the height of the cylinder. Then we have the radius here, the radius r, and the same radius from the base. All right. Now let's look at some examples of cylinders. The first one we can talk about milk tin. Milk tin is an example of a cylinder. We can have mackerel. We can even talk about mosquito spray, the container of a mosquito spray. We can talk about any cylindrical container, cylindrical containers. All right. All these are examples of cylinders. So we can also talk about the paper we have within toilet rolls. You know, every toilet roll has a paper like a cylindrical paper inside. Then the toilet roll will be rolled around it. So this one, it has a circular top and then a circular base. So this is also an example of a cylinder. We can have a plastic container. This is a plastic container. It has a circular top and then a circular base. And with this one, it also has a curved surface. So its surface is curved. So all these are examples of cylinders. Now, we are going to look at the volume of a cylinder. Volume of a cylinder. Now, before I give out the volume of a cylinder, generally, a volume of any prism is given by area of the base multiplying the height of the solid figure. This is a general formula for every volume of a prism. So you just find the area of the base, you multiply by the height. Now, because we are dealing with cylinder here, then the area of the base of a cylinder is a circle. And we know that area of a circle is pi r squared. So for the volume of a cylinder, it's going to be area of the circular base, times the height. We know that the base is a circle. In that case, area of a circle is pi r squared times the height. We are using h to represent it. In that case, volume of a cylinder is pi r squared h. As simple as that. Now we are going to move on to the curved surface area of a cylinder. So curved surface area of a cylinder. Every curved surface area, we can also call it the hollow cylinder. And when we say hollow cylinder, it is about, or it talks about, a cylinder with both ends open. A cylinder with both ends open. A cylinder with both ends open. An example is the paper we have within toilet roll. You could see that this side is opened and this side is also opened. So even when you use your eye to look through, you can use it to play, okay, like viewing something. You know, some kids, they used to play with these papers. Another example of a hollow cylinder is covert. There is this kind of concrete-like figure that we arrange when they are constructing bridges. So they just connect with one water to another water or river so that the water can pass through. So that is also an example of a hollow cylinder. Now we are going to look at how the formula can be determined. How do we get the formula for area of curved surface or a cylinder with both ends open? Now, this is a hollow cylinder. You know, both ends are open. There is nothing here, there is nothing here. Now, when I cut this figure with scissors into two, I can spread it to form a figure like this. Now, this figure I have obtained here looks like a rectangle, or is a rectangle. Now, before cutting, it was like this. So now this is the height. So before I cut it into two, it was like this, right? So this is the height of the cylinder. When I spread it, now the height will not be here. So this is my height, h. And again, before cutting it, this was circumference of a circle. The top here, or the base, is also circumference of a circle. So when I open, now this part will now be the circumference of a circle, which is 2 pi r. So this is 2 pi r, this side is also 2 pi r, and this side is also the height. Now, because it looks like a rectangle, area of a rectangle is length times the breadth. So if I want area of this curved surface area, then it can be written as 2 pi r times h. And 2 pi r times h, we are getting 2 pi r h. So this is the area of a curved surface, or the curved surface area of a cylinder. Now we are moving on to area of a cylinder with one end open. Area of a cylinder with one end open, or with one end closed. Now, the moment one end is open, automatically one end is closed. An example can be this container I have here. Now, this side is open, so this side is off, but this side automatically is closed. So if we want to find the total surface area of this cylinder or of this container, then we could see that one end is available. This particular side is available. And because this particular side looks like a circular, it's in the form of a circle, an area of a circle is pi r squared. So now this circular base is available from the container. It's available, so it's there. Then the curved surface area is also available. And we know that from here, the curved surface area is 2 pi r h. So I need to put them together. So if I want the area of a cylinder with one end open or with one end closed, then the formula is going to be pi r squared plus 2 pi r h. So this is the formula for finding area of a cylinder with one end open or one end closed. Now, the last one we are going to look at is area of a solid cylinder. Area of a solid cylinder. Every solid cylinder has both ends closed. So we can say that it's a cylinder with both ends closed. Both ends closed. Both ends closed. For example, is ideal milk. When you buy an ideal milk, the tin, the top is sealed, the base is sealed. Another example can be a mackerel. You can see that the top is sealed, the base is sealed. So those cylinders, we call them the solid cylinders or a solid cylinder. So both ends closed. Now, let me take this mosquito spray as an example. This is a mosquito spray. We can see that the top is sealed, the bottom is also sealed. So let's assume that I have cut the top with scissors or with any sharp object. I am going to get this cylindrical shape. So I have one in the form of a circle. Then I also cut the base, which is also in the form of another circle like this. So basically I am going to get two shapes all in a form of a circle. Now, area of each circle is pi r squared. This is also pi r squared. Now, after cutting the top and then the base, for which I have these shapes here, what will be left is the curved surface area or the hollow cylinder. And we all agree that the hollow cylinder or the curved surface area is 2 pi r h. So if I want the area of this solid cylinder, then I am going to get pi r squared plus another pi r squared plus the curved surface area, which is 2 pi r h. So from here we are going to put them together. Now we have pi r squared plus another pi r squared. We are getting 2 pi r squared plus the curved surface area, which is 2 pi r h. So this is the area of a solid cylinder. So viewers, we will end here and look at some sample questions under cylinder and how we can get their solution. Don't forget to subscribe. Keep on watching. If you know you have not yet subscribed, kindly do it now. Stay tuned. Bye bye.